It's time for Lecture 3 of Unit 14, the penultimate lecture of the year. This lecture deals with water pollution. In Lecture 1, we talked about water use. In Lecture 2, we talked about water management and water conservation. Now we're going to look at how we are screwing up our very precious freshwater resources. Because remember, 3% of the water on Earth is freshwater. And a huge chunk of that is unusable because it is in glaciers and ice caps. So we are left with surface freshwater and groundwater, and both of these can become polluted by a wide variety of human activities, and so we're going to spend the next 2 lectures talking about water pollution. This lecture, Lecture 3, is called Water Pollution. Next lecture, Lecture 4, is called More Water Pollution. So we're going to kind of divvy up the water pollution into a couple of different sections. So now that I've been long-winded about this, let's get moving. Water pollution. What is it? It is the introduction of waste or chemicals that are harmful to organisms into water. Alright? So pretty much every way we use water contributes to water pollution. Alright? Almost every way we use water leads to some sort of water pollution. Alright? Especially by this definition. Alright? If we go pee, well, we have used the water inside our body and we have added a waste matter into it and then put it back out in nature. Some water pollution, like that, all animals do, nature has a way of taking care of. So we're going to look at newer forms of water pollution, things that have been caused by industrialization and rapid human population growth. These are the 2 major causes for a lot of the water pollution we see today and for this problem getting worse in the future. One of the things we've noticed is that water pollution seems to affect the developing world a little bit more than the developed world. We are in the developed world. We have ways to treat the water, ways to make the water better for us. And we've made great strides in that. The developing nations are kind of learning from us, trying to clean up many polluted water supplies, but some water is still dangerously polluted. Alright, if you did some of that downstream web quest, you heard about the water walker, the lady who walks an hour and a half to go get water for her family every day. And a lot of times that water is dirty and has the remains of animal waste in it and everything, and it makes people sick. Well, that's polluted water. It is a big problem because sometimes the only drinking water available is already polluted, and it's either polluted with sewage or agricultural runoff, and both of these can spread waterborne diseases like cholera, like dysentery, which are diseases that attack the intestines and attack the digestive system, causing diarrhea and dehydration, and it just gets worse and worse. Well, we're going to look at water pollution and divide it into 2 sources. We're going to look at point sources and non-point sources, and kind of go on it from there and see the causes of it. And then, very end of Lecture 4, we'll talk about some of the things we have done, especially here in this country, to kind of take a step forward in helping clean up the water. So, point source pollution, alright, is probably the type of water pollution you think. You can think of a single source, or a point, like a factory, a treatment plant, an oil tanker. Point source is pollution discharged from a single source at a single place. You can point to the source. You can put a finger on the source. Alright? And while we can oftentimes figure out the source of point source pollution, it's hard to enforce cleanup. Right? So examples of point source pollution include a leaking septic tank or sewer system. Would happen in a residential area probably. Leaking storage lagoon. So sometimes if a company's making a lot of polluted water, they'll store them somewhere and those will start leaking. Landfills that do not get lined with concrete or substance to keep water in. Water will percolate through the landfill, pick up the toxic chemicals in the landfill, and then take them to the groundwater supply or somewhere else. There could be underground storage tanks. Just water released by industries. We'll talk about that a little bit more. Treatment plants, if the water's not treated effectively. And then mining operations can lead to point source pollution. So there's a ton of examples of point source pollution. The big thing with point source pollution, you can point to the single source. Non-point source pollution is pollution that comes from many sources rather than a specific source. Alright, this would be something like the water from streets and storm sewers. Alright, after heavy rainfall, if there's a lot of stuff on the street, that's all non-point source pollution. Or ice melting chemicals, salt and other icing agents, that's non-point. Water runoff from a whole city or suburban streets or areas is non-point source. Runoff of herbicides, pesticides, and fertilizer from farmland or residential land, really big. Agricultural waste, any kind of precipitation containing air pollutants. So this one right here, this would be acid rain, is non-point source water pollution. Acid rain can make an area of water more, an area of water more acidic. Alright, and so you can see a bunch of these as well. These are non-point source. They come from a wide range of areas. You can't just point right at the one source. It's a big, big area. Water pollutants themselves are classified into 6 different types. You got the pathogens, which are the things that cause disease. Organic matter is animal and plant waste and food products and stuff like that. Organic chemicals are the pesticides and herbicides and detergents and plastics, gas and oil that we use. Inorganic chemicals pretty much involve any kinds of salts and industrial chemicals that don't fit into the organic ones. Heavy metals are lead, mercury, cadmium, and arsenic, which are really bad. And finally, physical agents, which are really big suspended solids and also heat. Alright, and you can see under this major sources area where most of these come from. Alright, for example, pathogens tend to come from non-point sources. Alright, same with organic chemicals are non-point. Organic matter, non-point stuff. When we start looking at inorganic chemicals, the salts and stuff, unless it's road salt, the heavy metals, and the physical agents, that's where the point sources come into play, because we can follow them back a little bit easier than we can stuff like bacteria and organic matter. So water that leaves your house through the drain, whether it's the toilet drain or sink drain or shower drain, it connects to some sewage pipes probably, or it goes to a septic tank. Alright, and this is known as wastewater. Alright, wastewater is water that contains wastes, either from home or industry. And this water needs to go to a wastewater treatment plant. Alright, it's where water gets filtered and treated to make it clean enough before we put it back into a lake. Now, it doesn't make it potable. It's not drinkable right out of the wastewater treatment plant, but it's clean enough that it shouldn't harm the environment. And then that water gets taken back in and goes to a normal water treatment plant where it is made potable. Alright, and again, it involves a lot of different physical and chemical means. Here's an example of a wastewater treatment plant. You can kind of see a real one here instead of the picture on the other one. And a lot of times the wastewater from home contains biodegradable material that gets broken down by living organisms, so it's not as bad putting it back out into nature. So wastewater from toilets and sinks, a lot of times, all right, especially toilets, they contain a lot of human waste, which can be broken down by organisms. Same with animal and plant wastes and paper. Those are all coming from organisms. Even soap is now a lot of times made through more natural-like processes, and they're not as chemical heavy as they used to be. Some household and industrial water and a lot of storm water contain toxic substances. These are the heavy metals and inorganic chemicals that we don't see that much, and these have to be removed by different treatment ways, and these can get into lakes and rivers and everything and cause big problems. The problem with wastewater treatment is then you get this very thick, gooey, smelly, stinky, solid material called sewage sludge. Alright? And it can be dangerous because it can contain lots of toxic chemicals, and we have to get rid of it because it is a hazardous waste. You can't just throw it out in nature. You just took it out of the water to keep it from getting into nature. So now we have to find a place for it. And one of the things that we can do is we often burn it and then take the ash and we bury the ash in a secured landfill. And some of those toxic chemicals are still in the ash, but they're stuck in the ash. And if we put them in the right kind of landfill, they won't get out. We'll put it in a lined landfill, not one that's unlined. If you put it in an unlined landfill, water will go through the ash, pull some of these toxic chemicals out of the ash, and then you're polluting the water again. The biggest problem with sewage sludge is disposal, and we're trying to figure out different ways to make use of it. If we can somehow get those toxic waste down to safe levels, sewage sludge is an excellent fertilizer because it's got a lot of material that can be decomposed and broken down into the nutrients that plants need to grow. But you gotta first take out the toxic chemicals, and that is the hard part of this. Another major problem that we end up with is something called eutrophication. And what eutrophication is, it is again dealing with the nutrients. So nutrients in water tend to come from organic matter, all right? Decomposing leaves, decomposing animal waste get broken down into the minerals that make them up. And bacteria and fungi do this, and they do it really well. And we need nutrients in lakes and freshwater ecosystems to kind of build up that base level of the food chains. The lowest trophic level of the area needs these nutrients. And when these lakes and streams contain too many of these nutrients, contain a big abundance, we call them eutrophic. And eutrophication, big thing here, it's a natural process. It happens without our involvement at times, but we sometimes speed it up or make it worse, as we'll talk about in a couple of slides. So when you have a lot of this organic matter building up, all right, it starts to break down and decay. It starts to be broken down, all right? The feces gets broken down, or the plant parts get broken down, the dead leaves get broken down, and they decompose. As things decompose, they use up a lot of oxygen, a lot more oxygen to decompose stuff than just something needs to normally live. So these bacteria breaking everything down cause the oxygen levels in the water to decrease, which causes the types of organisms that live in the water to change. So plants can take root in the nutrient-rich soil, and as more plants grow, the shallow waters fill in, and eventually, instead of a lake, we have a swamp or a marsh. And Fish don't live as well in swamps and marshes. So eutrophication tends to lead to less animal life in the body of water, but more plant life in the body of water. The problem with eutrophication from our standpoint is when we accelerate the process, called artificial eutrophication. So normally you got nitrogen and phosphorus getting into the water. Usually they get into the water from just decomposition of stuff. Here's the decay, it uses up the oxygen and everything. And phytoplankton will grow on the grasses inside the water, the seaweed. All right. But as these phytoplankton and algae grow, they start taking over the top, and then as they die, they need to get broken down, which uses up more oxygen, and you just get this vicious cycle where there's not enough oxygen in the water to support large populations of animals anymore, because there's too much nitrogen and phosphorus, causing an explosion of these phytoplankton and algae, which overall we lose food, habitat, and oxygen production inside the water, which ends up not being good. The reason we call it artificial eutrophication, it's because we increase the amount of those phosphorus and nitrogen nutrients through human activities. Mostly, it is coming from fertilizer and phosphates used in either laundry detergents or by the runoff of fertilizer from the hills. Honeoye Lake, all right, it's a lake between Canisius Lake and between Canisius and Canandaigua. It's a small little lake. It's about 5 miles long, about a mile wide. It only gets to 30 feet deep. It's like a glorified pond, but technically it's a lake. Honeoye Lake, come June, or come the end of summer, come the end of July and August, definitely late August, gets really green looking. The water's not all that bad looking in June and July. I was in it a couple weeks ago putting a dock in for my father. Not too bad. Pretty clear. Water's cold, but it's kind of clear. Maybe a little murky, but nothing horrible. As we get to the end of summer, you'll start seeing like big algal blooms, these big things of algae growing on the surface and floating by. It's going to turn green, and that's due to the phosphorus and the fertilizer coming off the hills that are big agricultural land. So the farmers use a lot of fertilizer to grow their crops real nice, so we can buy big juicy tomatoes or whatever. But some of that fertilizer gets caught in rainstorms and runs off the farm and into the streams, which go and feed Honeoye Lake and then gets into the lake. And so it promotes the excessive growth of algae. Then these algae will die eventually, because things die, and they start to decompose. And as they decompose, more of the oxygen in the lake gets used up, and fish and other organisms have trouble breathing in the oxygen-depleted water, and it can get really stinky. They closed down Honeoye Lake a couple summers ago, near the end of summer, just because it got really eutrophic, really bad in there. That there were a lot of bacteria decomposing stuff. It was not safe to swim in for people. It could make them sick just because of the high concentration of algae and bacteria. And fish populations decreased in there because of this. So here's the final picture of this lecture on the final slide of this lecture. It's a little more complicated, a lot of the same thing as the other one. Here we have our water source right here. You can see farmland. All right, and the big thing here is the surface runoff. All right, all those fertilizers. The N's are nitrogen, the P's are phosphorus. All right, they get run into the lake, and so you get phosphorus and nitrogen into the lake. In this case, there's a reservoir because we got a dam here, but we got this into the river, into the reservoir, and that causes the algal blooms, and it causes a loss of oxygen in the water and makes a change to the ecosystem of that area, which will have a big influence on the things that are living there. We will finish up with some more talk on water pollution in the last lecture of the year. If you have any questions, please write them down, bring them in, come ask them. Major things from this: know where water pollution comes from, know point versus non-point, examples of each, know the 6 major types of pollutants, and know what wastewater is and what eutrophication is. And like I said, we'll get into the last little bit of water pollution next lecture. And we'll talk a little bit of some of the regulations we've put in place over the last 50 years or so to try to clean up the water. And keep in mind, we've done a good job of this. Water in the U.S. is getting cleaner. Right? There were rivers that would catch on fire in Ohio back in the 70s. The river was so polluted it could catch on fire. We don't hear about that anymore because we've done a better job regulating what can go into water and being able to clean the water up. So again, have a good night and thank you very much.